Hey guys, StatsGuru here, and in today's video I want to touch on the subject of sample variance and sample standard deviation. So in this video I just kind of want to walk through their definitions, just a recap of what they're used for, and then let's look at two formulas for sample variance. I get a lot of questions on which one to use, and I'll kind of show you that it's personal preference. There isn't necessarily a right or wrong answer. But we'll go ahead and we'll walk through some examples towards the end of the video here to get some practice with that. So to start off, sample variance. Well, sample variance in statistics is usually denoted with a lowercase s squared. So that's typically how in statistics we denote sample variance. And if we think about sample standard deviation, well, the deviation is the square root of the variance. So standard deviation is simply the square root of s squared. So that's how we find the variance and standard deviation. So to recap what sample variance and standard deviation are, let's go ahead and draw this out. So let's say we have a population mean here. And let's say we have one sample that has a really small variance. And let's look at an example where we have a really wide variance. So as we can see from this chart, one of them is tighter and skinnier than the other. And that's exactly what sample variance and standard deviation tell us. It helps us understand the spread of our data from the mean or the average. So how far and how long and big is our mound or normal curve when looking at the variance of our data set. So we can see that one of them is much tighter and much skinnier than the other. So if we think about the yellow group, let's say that has an s squared of 10, and the green group has an s squared of 100. Right, so we can see how the spread of this data is so much wider. So much wider, so much bigger, so much longer across the mean, meaning that our data has really wide spread. There's all kinds of values around the mean, whereas the yellow group is pretty concentrated. Everything is pretty concentrated around the mean value. So that's what we like to see. We like to see a small variance, meaning that our data doesn't vary as much from the mean. So that's kind of a recap of what these two things are telling us. So if we're going to think about sample variance, there are two formulas to be familiar with. So the first formula is the sum as I goes from 1 to our number of items of xi minus x bar squared, and we're going to divide by n minus 1. So that's the first formula to know. So, just to recap, as our observations go from 1 to n, we're going to take each observation and we're going to subtract the sample mean, and we're going to square that value, and we're going to add this up over time until we reach our n value. Once we reach the total sum of those values, we're going to divide by n minus 1. So the n minus 1, a lot of people ask me, why do we do that? It's simply a correction factor. So think of this as calculating correction of error, right? If we have a very small sample in our population, it's not going to be as accurate as taking a larger sample. So if you picture this n getting bigger and bigger and bigger towards infinity, the minus 1 becomes insignificant. And basically this helps correct for very small sample sizes. You can think of it that way. The second formula we typically see with sample variance is the following. So as we add up the square of our observations and we subtract the total sum of our observations squared divided by n, we then divide by n minus 1. So this is the second formula that we typically see when dealing with sample variance. Some pros and cons to each one. The top, or the first formula here, is usually the traditional. So this is usually the traditional formula. It's pretty calculator intense. meaning you have to add up and do this summation on the calculator with the parentheses and square it, and then you have to add the next parentheses and square it. So it can be a lot of calculator work and can be very intense. The second formula is typically quicker. If you think about doing this on the calculator, all you have to do is add the squares of each value and then subtract and add up all of your values and square that answer, and then divide by n. Make sure you remember that part, and then you minus those two numbers, and then you divide by n minus 1. So it's a little less calculator intense, it's a little bit quicker to find. However, the downside with this formula is simply keeping track of multiple numbers. Right, you need to keep track of this number, you have to keep track of this number, you need to remember this value here, and then you have to remember the bottom. So that's kind of the downside with it. Even though it's quicker, there tends to be more thinking involved in remembering what you need to do. So that's just a quick recap of the sample variance, what it typically looks like on the graph, and then the two formulas that are used to calculate it. Once you find your sample variance, you simply just take the square root of that answer, and that will give you your standard deviation. So the standard deviation is relatively simple. The only legwork is making sure that we find the correct s-squared value. So now that we know both formulas and a recap, let's go ahead and look at a couple examples. And in those examples, I'm actually going to walk through using both formulas, and you'll see the anomaly that both of these things are relatively the same as far as finding the correct value. So we'll walk through those examples now. In this first example, let's look at our 25-yard sprint in seconds. So I've ran this 5 times and I took my time down in seconds, and let's measure the variance of my time on the 25-yard sprint. So using the first formula, let's find our s-squared. So in order to do that, we would take 3.2 minus 3.14 squared plus 2.9 minus 3.14 squared, so on and so forth until we get to the end, and then we would divide that number by 4. And I've done this ahead of time, but I challenge you to see if you get the same answer as me. So s squared is equal to 0.053. So our variance is equal to 0.053, and if we were to find our standard deviation, we just take the square root of that number, and we get 0.230. So I have a variance of 0.053 seconds, and I have a standard deviation of 0.230 seconds. So that's using the first formula. Let's now calculate this with our second formula. So if you recall, s squared is equal to the sum of xi squareds minus the sum of xi squared divided by n minus 1. So let's take the first part. So we're going to take 3.2 squared plus 2.9 squared, etc., etc., and that gives us a value of 49.51. The next part, 3.2 plus 2.9, we're going to square that and we're going to divide by 5. That gives us a value of 49.30. So now we're just going to take 49.51 minus 49.30, and we're going to divide by 4. And that gives us a value of, lo and behold, 0.53. So you can see that we get the exact same answer using both formulas. So when people ask me, which formula is better, which formula should I be using, it's really personal preference. Do you want to do all the long calculator work here on this formula? Or would you rather keep track of specific numbers and then do the mathematical computation at the end? It's really up to you. Either way, we get the same answer. So this is the first example using both formulas. Let's go ahead and look at another example. For this example, let's say a college campus wants to survey students and measure how many hours of TV, Netflix, Hulu, etc. that they watch on a weekly basis. So let's say we sample 9 students and we find out that they watch 1 hour, 3 hours, maybe 7 hours, 7 hours, 6 hours, 8 hours, 4, 3, and 2. So we take a sample, and here are the number of hours of TV that they watch on a weekly basis. And we're asked to find the variance of this sample. Well, to first do that, we need to calculate our sample mean. So our x bar is 4.556. So that's how many hours on average students are watching on campus in a given week. And let's go ahead and use both formulas to calculate our s squared. So in the first formula, we would take 1 minus 4.556 squared plus 3 minus 4.556 squared, and we would keep doing that. And once we get that final number, we're going to divide by 8. And once we do that, you should be able to see that our s squared is equal to 6.28 hours, and our standard deviation is 2.51 hours. So that's using the first formula. Let's go ahead and look at the second formula. The first part of the second formula is taking the sum of the squared values. So we would take 1 squared plus 3 squared plus 7 squared, which would give us a value of 237. The next formula is the sum of our values, and we're going to square the answer. And then we're going to divide it by 9. So that gives us a value of 186.78. Then the formula tells us that we're going to take 237 minus 186.78, and then we're going to divide by 8. So our s squared value is equal to 6.28 hours. We can see that we get the exact same answer using 2 different formulas to calculate the variance. And of course, our standard deviation would then be the same, right? 2.51 hours. So that's another example of using both formulas, calculating the number of TV hours that college campus students watch on a given week. We have our sample, we calculated our mean, and then we went ahead and used both variance formulas to figure out the number of hours and then our standard deviation. So that's the second example using both formulas. In our third example, let's say we are going to look at the mile per hour of a baseball pitcher and how fast that he can throw. And let's say we take a sample of 10 pitches and we get the mile per hour of 76, 73, 92, 94, 88, 82, 77, 83, 96, and 85. So let's say that this is our sample of pitches of an MLB pitcher, and we want to find the variance. So first we need to find our x bar value. So our x bar value is equal to 84.6 miles per hour. And then once we know our sample mean, we can calculate our variance. So let's use the first formula. So formula 1, s squared is equal to 76 minus 84.6 squared plus 73 minus 84.6 squared, etc., etc. Then we're going to divide by n minus 1, which would be 9. And once we go ahead and do that, we calculate the s squared to be 62.27 miles per hour, which gives us a standard deviation of 7.89 miles per hour. So that's using the first formula. So for our second formula, we're going to have our xi squared values, which equals 76 squared plus 73 squared, etc., etc. And that gives us a value of 72,132. The next part is we're going to take the addition of all of our values and square it, and then we're going to divide by 10. So that gives us 71,571.60. Then we're going to take the subtraction of these two, so 72,132 minus 71,571.6, and then we are going to divide by 9. So our s squared is equal to 62.27 miles per hour, and our standard deviation is the same, 7.89 miles per hour. So there you have it, another example where you could use either formula and get the exact same answers. So I hope that this video was helpful for you guys, walking through a couple examples of how to find a sample variance as well as a standard deviation, and looking at how both formulas get you the exact same answer. As always, feel free to leave any comments down below of topics that you want help with. I'd be happy to make a video for you. Make sure to like and subscribe, and we'll see you in the next video.